According to a new study, aliens may be hitchhiking rides on meteors to colonize the cosmos. And here's how we could spot them if they're doing that. A fringe theory called panspermia suggests that life forms can spread to new planets by hitching rides on meteors, that's celestial bodies, in other words, meteors, asteroids, comets, whatever. New study lays out a roadmap for finding where these hypothetical planet-hopping aliens may reside. And here we have an illustration of an impact crater on Mars, an impact crater from a celestial body that impacted Mars, of course. If life is capable of spreading from planet to planet, a concept known as panspermia, then we might be able to detect it even if we don't know what we're looking for, a new research suggests. Astronomers are on the hunt for life beyond Earth. While there are several promising locations within our solar system, the sheer abundance of exoplanets seems that we are most likely to find life on a planet orbiting another star. There are more than 5,000 confirmed exoplanets up to now, according to NASA, and that number is always rising. But the searches for extraterrestrial life currently face one major roadblock. We don't know exactly what we are looking for. We only know of one kind of planet that is definitely capable of hosting life, and we only know of one kind of life, that is Earth, and the carbon-based life that is found here. But life may, say astronomers, take an astonishing number of forms throughout the galaxy, while we might get extremely lucky and find an exact replica of Earth with the exact same kind of life. We're more likely to face fuzzy, unclear nuanced situations that will take many years to unravel. A pair of astronomers recently proposed an alternative to this approach, focusing less on what life would look like and more on what life would do. Specifically, they propose a detection strategy based on the concept of panspermia. That's the idea that life can start on one planet and spread to other planets by hitching rides on celestial objects. While panspermia lies outside the mainstream of scientific research, it's not outright pseudoscience either. Martian meteorites have been found on Earth, and scientists are routinely surprised by the hardiness of living creatures and the extreme environments that they can survive in. One of the key characteristics of any kind of life is its ability to change a planet's natural balance. On Earth, for example, we have far more oxygen in our atmosphere than we would if we were not present, and distant observers would notice much more green on our land masses than there would be otherwise. Now, we don't know exactly what properties of an exoplanet that alien life would change, but if that life is capable of panspermia, then it would attempt to make those same changes on every planet it came across as it spread from world to world. Sometimes it would fail if the conditions were not right to allow that life to thrive, but sometimes it would succeed, making the new planet similar to its original world. And then that new planet would serve as a starting point for a new round of panspermia. In their new study, the researchers devised a statistical test where if we measure enough properties of enough planets, then we can potentially identify a cluster of nearby planets that share similar characteristics, since these planets, each one orbiting a distant star, would have no other reason to be similar to each other. This cluster would stand out from the collection of all exoplanets. Such a discovery would not be a smoking gun for identifying life, but it would be a major clue that something strange was happening on those planets, and that the cause just might be life propagating among the stars. The researchers acknowledge that their work has limitations. First, it assumes that panspermia is possible, which is an untested hypothesis up to now. Secondly, their technology only works if we can collect data about a large number of exoplanets, but the advantage of their technique is that it's agnostic, meaning that it can identify a potential signature of life without any bigger assumptions about how that life works. The team's research was published in March to the preprint database ARXIV and has not yet been peer-reviewed. This is by Paul Sutter on Live Science. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.